Hello everyone. If you're studying for the AP Calculus AB or BC exam, this is going to be some practice for you, but I'm going to be solving and going through the first 10 problems of sample questions for these two exams. And this was published in 2014, so let's get started. So, start with problem one. Here we can see there's a limit. It says the limit as x approaches pi of cosine x plus sine of 2x plus 1 divided by x squared minus pi squared. Now, when I look at this limit, I see that this is going to likely be a L'Hopital rule, because if you look at the denominator, it's x squared minus pi squared, and if we substitute x equals pi, this becomes pi squared minus pi squared. The numerator becomes cosine of pi, which is -1, plus sine of 2 pi, which is 0, plus 1, so -1 plus 1 is going to be 0, so 0 divided by 0, which is going to be a L'Hopital's rule. Now, to use the L'Hopital's rule, we need to take the derivative of the numerator and the denominator. So we can take the limit as x approaches pi of the derivative of the numerator, which is going to be negative sine x plus 2 cosine of 2x using the chain rule divided by 2x. Now we can substitute pi without worrying about division by 0 issues. So this becomes negative sine of pi is going to be 0. 2 times the cosine of 2 pi is 2. Divided by 2 pi is going to equal 1 over pi. And our answer is B. Moving on to problem 2. We have a limit as x approaches infinity of the square root of 9x to the fourth plus 1 divided by x cubed minus 3x plus 5. Now, this numerator here, it's essentially equal to 3x squared. Well, the reason why is that if we take the square root of 9x to the fourth, it's equal to 3x squared. This plus 1 here, this is irrelevant, because as x approaches an extremely large number, this plus 1 is not going to do anything, because only the largest power here is going to matter. So this is going to equal 3x squared divided by x squared, which is equal to 3. And answer is equal to 3. Now, the reason why behind is because as we take an extreme large number, so let's just say, 9 times a trillion to the fourth plus 1, square root of that number divided by a trillion squared minus 2x plus 5. The plus 1 and the 3, -3 trillion plus 5, they're not going to do anything. They're insignificant compared to the 3x squared in the numerator and the x squared in the denominator, which is why the answer is equal to 3. Moving on to problem 3 here, we have a piecewise function. The graph has a vertical tangent at x equals 2, right here. And the graph has two horizontal tangent lines at x equals -3 and at x equals -1. And the question is asking us for this graph where f is continuous but not differentiable. Now, so our answer choices. Now, right off the bat, we can see that B and D are going to be wrong. And the reason why is at x equals 0, the function is not continuous in the first place. And if a function is not continuous, it cannot be differentiable, because these two limits don't equal to each other. Now, for A and C, at x equals 1, we can tell that it is continuous, not differentiable, because there is a cusp. We can see that f of 1 is equal to 0, but the derivatives, there's a cusp. There's a really extremely quick change in the derivative. And at x equals -2, we can see that there is a vertical tangent, which means that the function is not differentiable at x equals 2. But we can still see that at x equals 2, the function is likely equal to, f of -2 is likely equal to 1, which means it's continuous. So the answer here is C. Moving on to problem 4 here. This looks like a related rates problem. We have a sphere of an ice sculpture, and the volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. So as you're doing these related rates problems, the best thing you can do is you're going to note down the characteristics or the information that you're given So far we're given that the volume is changing at a rate of 2 pi cubic meters per hour. At what rate in square meters per hour is the surface area of the sphere decreasing? So we're looking for the surface area, the rate of change of the surface area. So ds dt is equal to question mark. When the radius is equal to 5 meters, radius is equal to 5. And let me make this a little smaller here. So to find ds dt, we have to differentiate the formula for the surface area. So s is equal to 4 pi r squared. Take the derivative, we have ds dt is equal to 8 pi r. Don't forget the dr dt because this is with respect to time. Now here we have the radius, which is 5. We don't have the rate of change of the radius with respect to time. And we can find that by taking the derivative of the volume. So here we're given the volume formula, which is V is equal to 4 over 3 pi r cubed. We can take the derivative of this, which becomes dV dt is equal to 4 pi r squared dr dt. Now here we can actually solve this because we have dV dt. Unlike ds dt, we're trying to look for it. So we can substitute our values in. 2 pi is equal to 4 pi times the radius, which is equal to 5, so 25, 5 squared is 25, times dr dt. And from here, we can say 100 pi, so 2 pi is equal to 100 pi times dr dt, so dr dt is equal to 1 over 50. Running out of space here. And now we have our dr dt, we can finally solve for the rate of change of the surface area. So ds dt is going to equal 8 pi times the radius earlier, which is 5, times 1 over 50. And this is going to equal 40 pi divided by 50, which is equal to 4 over 5 pi. Next, we have a slope field. So for slope fields, let's look at our answer choices. So whenever you have one variable in the answer choice, whether it's only y, as seen in answer choice C, or whether it has only x, answer choice D, this means that the slope has to be the same. If it's the same, if it only has y, it means the slope field has to be the same across all x values. And if it only has x, it means the slope field each slope has to be the same for every y value. Now this is not the case because we can see here that the slope field is negative, 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 and it becomes undefined here, and then it becomes, well, it's 0, but becomes 0, and then it becomes positive, 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 positive. And same thing, as you can see, if we go vertically, we have a negative slope field all the way down to 0 right here, and then slope field becomes 0 and then goes to negative, which means it can't have a single variable because the slope field is dependent on both variables in this case. So we can say that C and D are automatically wrong. And here we can just kind of use process of elimination. So let's take a random point here, this point, which is 3 comma 0. And we can substitute these values into one of these functions, well, both of them. So we have dy dx is equal to 3 times 0 plus 3, which is equal to 3. That's positive. And this is positive, which matches. For b, dy dx is equal to 3 times 0 plus 0, which is equal to 0. And as we can see at 3 comma 0, the slope is not a flat line, flat horizontal line. It is a positive slope, so A is correct. Next, we have a piecewise linear function defined above. Let's start with I here. So the limit as h approaches 0 from the left side of f of 3 plus h minus f of 3 divided by h is equal to 2. So let's check this. So f of 3 plus h, and this is as h approaches 0 from the left side, so we have to use this function over here. So we have f of 3 plus h, so we have to substitute x in this function for 3 plus h. So 2 times 3 plus h minus 2 minus f of 3. Now for f of 3, we need to use this bottom function, and we can see from f of 3, it's going to be 2 times 3 is equal to 6 minus 4, which is 2. So this becomes 6 plus 2h minus 4 divided by h. Now this is equal to 2 plus 2h divided by h, which can also be simplified to 2 divided by h plus 2h divided by h, which is equal to 2 divided by h plus 2. And as h approaches an extremely small number from the left side of 0, which means it's going to be a negative 0.0001, negative 0.00001, this is going to be negative infinity plus 2, and this 2 is irrelevant. So this is going to equal negative infinity, and I is not correct. Okay, so we can automatically eliminate C and D here, and let's check number 2. 2 is different because now we're approaching 0 from the right side. So now we're using this function for 3 plus h. So we substitute, same thing, we substitute 3 plus h in place of x. So 2 times 3 plus h minus 4 minus f of 3, which we found earlier was 2, divided by h. This is 6 plus 2h minus 6 divided by h. This is just 2 here if we simplify everything. And this is actually correct. So we don't need to check if it's none, obviously. So B is automatically correct here. On to question number 7. If f of x is equal to the integral from 1 to x cubed of 1 divided by 1 plus the natural log of t dt for x is greater than or equal to 1, then f prime of 2 is equal to. So let's first find f prime of x. So f prime of x is equal to, so for taking the derivative here, we can use a fundamental theorem of calculus, and this becomes 1 plus 1, 1 divided by 1 plus the natural log, and we substitute this upper endpoint in, which becomes natural log of x cubed. And remember, we have to take the chain rule, so we need a derivative of this too. So times 3x squared. So we have f prime of x is equal to 3x squared divided by 1 plus the natural log of x cubed. Now we can just substitute in. Now we can just find the derivative at x equals 2. So this is 3 times 4 divided by 1 plus the natural log of 8. And we can see that answer choice D is correct. On to question number 8 here. Which of the following limits is equal to the integral from 3 to 5 of x to the 4th dx? So this is finding the area of a function under a function, except we're expressing it as a Riemann sum. And for a Riemann sum, remember, to find the area, if we're given a function like this, we're taking extremely small rectangles, and these rectangles have an extremely small width, but we can't actually see that, right? It's an infinite number of rectangles meant to represent the area under the graph from point A to point B. And I'm just drawing this, but there's obviously an infinite number of rectangles. So obviously the formula to finding a rectangle is length times width, or base times height. And the base is always equal to 3, or not 3 actually. It's equal to the first endpoint, a plus k, times the width, which is, and how do we actually find the width? Well, the width is the distance between these two endpoints divided by the number of rectangles. And the number of rectangles here is infinity, but we're just going to represent infinity as n here because we're trying to find the limit as n approaches infinity. So it's going to be an infinite number of rectangles. So a plus k times the change in x, which is the width, times the change in x. And if we use this formula, a here is 3 plus k times the change in x. And the change in x here is 5 minus 3. So that's the total distance. That's total. So if we draw this graph here, it's going to go something like this, except it's more exaggerated because it's x to the fourth. And this is 3, and this is 5. X equals 3 and x equals 5. And we're trying to find all this area underneath. So we have to find this total distance under here. 5 minus 3 divided by the number of rectangles, which is n. So I'm going to find an infinite number of rectangles. So 3 plus k times 2 divided by n. And remember, all of this is substituted into x. So this is all to the fourth. I mean, not all to the fourth, actually, what am I saying? This part here is to the fourth times the width. And if we match our answers up, this is going to equal, it's going to be d here. And on to question number 9. Function is continuous, and the graph shown consists of 5 lines. What is the average value of f? So we can use the average value formula, which is 1 over b minus a. And so here we have a, negative 4 is a, and 4 is b. From a to b of f of x dx. And we can just, we don't actually have this, but we don't actually have the function, the f of x function, but we can basically find the area under f of x from a to b, from negative 4 to 4. So if we count these squares, we have 1, and then this is 2, but this is underneath the graph. So, and this is 1, and then this is 2. So this is 3.5. So the integral from negative 4 to 4 of f of x dx is equal to 1 minus 3 plus 3.5, which is just equal to 1.5. And this has to be divided by 4, 4 minus negative 4. And so this is 3 over 2 divided by 8. And our answer is 3 over 16. Which means the answer choice B is correct. And the last question, 10. So let y equals f of t be a solution to the differential equation dy over dt is equal to ky, where k is a constant value. Values of f are selected for given t values, and which of the following expressions is an expression for f of t. So this is going to be a separation of variables problem here. So to separate this, we first need to separate dt and y. So we have dy over dt is equal to k times y. So we have to move the y to the other side, where we see the dy is on the left side of the equation. So we divide both sides by y. We have 1 over y dy dt is equal to k. Now we have to obviously move the dt over too. So we have 1 over y times dy is equal to k times dt. And now we have to take the integral, because these two are both rates, and we need to find the expression. So to take the integral of 1 over y dy is natural log of the absolute value of y is, and for this one, it's k plus c, or k squared, kt, actually, kt plus c. And now we have to find the expression for y is equal to f of t. So we can take both sides to e. So we can raise both sides by putting e in the, well, e to the natural log of y is equal to e to the kt plus c. So this simplifies to the natural log, I mean not the natural log, the absolute value of y is equal to e to the kt plus c. And, well, we actually need to first find c. What am I doing? Okay, so if we substitute a t value in, if we substitute t for 0, we have the natural log of 4 is equal to 0 plus c. So we know that c is equal to the natural log of 4. Let's move it back up here. So we have the natural log of the absolute value of y is equal to kt plus the natural log of 4. And we can use e here. So we have the absolute value of y is equal to, so e to the power of the natural log of 4 is just going to be 4. 4 times e to the kt. And now we have the absolute value of y is equal to 4 times e to the kt, and we can use this one right here. So we're given that 12 is equal to 4 times e to the k 2 times 2. So if we do it like this, so divide both sides by 4, we have 3 is equal to e to the 2k. And we can take the natural log of both sides here. So the natural log of 3 is equal to 2k, well, natural log of e to the 2k, and this can be simplified to the natural log of 3 is equal to 2k. So now we know that k is equal to the natural log of 3 divided by 2. Now we could finally substitute k. Now we finally found what k is here. So going back to this, we have the absolute value of y is equal to 4 times e to the natural log of 3 divided by 2 times t, and that's our final answer. And we can see from here that our answer is going to be a here, and that's our final answer. I want to thank you guys for listening. It's been quite a long video, and I'm going to be doing the rest of these problems in another video. And if you have any suggestions, let me know in the comments.